Hi everyone, hope all of you are doing well. In this video, we are going to talk about hypothesis testing for a population mean when population standard deviation is unknown. So, before solving any question, let me remind you the steps we have in a hypothesis testing question. So, when you are going to do hypothesis testing, in the first step, you need to formulate H0 and H alternative. Okay, we need to formulate null and alternative hypotheses. In step two, we need to select a level of significance. But when you solve a question, level of significance is given in the question. Then in step three, we need a sample. I need information about the sample. In step four, I need to identify the rejection region clearly, as well as the cutoff point. Okay. In step five, I need to calculate a test statistic. Okay, look at here. Here we are going to do a hypothesis testing for a sample, for a population mean. Okay, so when we are going to do a hypothesis testing for a population mean, I need to calculate the test statistic for X bar. If sigma is given in the question, if population standard deviation is known, the test statistic would be z value of X bar. But if sigma population standard deviation is unknown, it's not given in the question, I need to find the t value of sample mean. Okay, t value. And in step 6, I need to decide about rejecting or not rejecting H0, null hypothesis. Okay, so in step 5, I told you when sigma is unknown, we need to calculate t statistic, t value for X bar, if we do a hypothesis testing for population mean. Look at here. T value of X bar can be found by using this formula. When sigma is unknown, I'm going to use this formula to calculate the test statistic. Okay? T is X bar minus mu. X bar is sample mean, mu population mean, over S sample standard deviation. S is sample standard deviation and N is sample size. By using this formula, we can find the test statistic for X bar. T is critical value from a T distribution. What is the T distribution? A T distribution or a student's T distribution is a symmetric distribution centered at 0. Okay? Look at here, it's symmetric, bell-shaped, centered at 0, it's T distribution, but it's a little wider. Okay, wider than Z distribution, but it's 0 centered. Okay, this distribution has a single parameter called degree of freedom, df. Degree of freedom is linked to the sample size. df is linked to the sample size. df always is sample size minus 1. Now, let's do a hypothesis testing for a question when population standard deviation is unknown. Look at this question. Question says the mean daily spend of college students was $60. We have a population of college students. The mean value of the mean daily spend of these college students is $60. Okay, so they decided to adapt cost-cutting measures to save some money. To evaluate the effect of these cost-cutting measures, a random sample of 26 students selected. Look at here, they have selected a sample of 26 students, and this sample reported a sample mean of $56.42, sample mean, and standard deviation of $10.04. It's sample standard deviation. Sigma population standard deviation is unknown. Question says at the 0.01 significance level, it's alpha. Can we conclude that the mean daily spend is now less than 60? Okay, we are going to test if after applying these measures, the mean daily spend of students is less than $60. Okay, I'm gonna apply the steps we have for hypothesis testing on this question. Look at here. We are going to do these steps for this question. Okay, look at here. In step one, we need to formulate step one. In step one, we need to formulate H0, null hypothesis, and alternative one. Okay, so look at here. We are going to test if the mean is less than 60. Population mean is less than 60. Write that as a math expression. Mu is less than 60. Can it be the null hypothesis? No, because we don't have any equal sign. So we already made H alternative, H1. Because if you remember, we must have the equal sign in H0, the null hypothesis. So as a result, H0, the null hypothesis would be mu is more than or equal to 60. H0 and H1 must cover all the possible values for the parameter, for the population parameter, for the mean. So when H1 says mu is less than 60, H0 says mu is more than or equal to 60. And we have the equal sign always in null hypothesis. Step 1 is done. Now step 2. In step 2, I need significance level. Okay, so step 2, I need alpha. Alpha is given in the question. So alpha is probability of making type 1 error. In a video, we talked about that. Or level of risk, level of significance is 0.01. In simple words, alpha is the area of the rejection region. Okay. So step 2 is done. Now step 3. In step 3, I need a sample. Okay, in this question, we have the information about the sample. We have a sample of 26 students. Sample mean X bar is $56.42. Sample standard deviation S is $10.04. Okay, step 3 is done. Now step 4. In step 4, I need to identify the rejection region clearly. Okay, so it's the distribution of X bar. Okay, bell-shaped. Okay, so I need to identify the rejection region here, if it's on the right side or on the left side. Look at the H0 and H1. We don't have equal sign and not equal sign. We have more than or less than. So here we have a one-tail test. But is the tail on the left side or right side? An easy way to identify if the tail rejection region is on the left side or on the right side is to look at H alternative. H alternative says mu is less than 60, okay? When in H alternative we have less than, the rejection region always is on the left side. I explained about them in a video, okay? You can watch that video also. If H alternative says mu is more than 60, the rejection region would be on the right side, okay? Here I have a one-tail test, okay? And because we don't have equal sign and not equal sign, it's not a two-tail test. We have a one-tail test, and tail rejection region is on the left side. So we have a rejection region on the left side. It's the rejection region. The area under the curve of this rejection region, the red part, is alpha, 0.01. Okay, now to identify the rejection region clearly, I need this cutoff point. Okay, look at here, this cutoff point shows which part is not reject region and which part under the curve is reject region. Okay, I need this cutoff point. Look at here, on the left side of this cutoff point, I have the rejection region. If the t-value of x bar sample mean falls within the rejection region, I'm gonna reject H0. Otherwise, if the t-value here, because sigma is unknown, I'm gonna find the t-value of x bar in step 5. If the t-value of x bar falls in the not reject, look at here, the red part is reject region on the left side. On the right side of this cutoff point, I have not reject H0, don't reject H0. If the t-value of x bar falls within this rejection, on the right side or not reject region, we don't reject H0, okay? So let's find this cutoff point. I know the area on the left side of this cutoff point is 0.01. So by using an inverse function in Excel, I can find the cutoff point, okay? Here, because sigma is unknown, I need to use t, and we have a one-tail test, okay? I'm going to use t period inverse function in Excel. Let's go to Excel. So look at here, to find the cutoff point, I'm going to use t inverse, okay? So this function returns the left tail inverse of the t distribution, okay? And I need to enter I'm looking for the cutoff point. The area on the left side of cutoff point is 0.01. I need to enter that here, and the degree of freedom. Degree of freedom of the T student always is sample size, 26 minus 1. Look at it, it's the Excel file for the same question. We have X bar sample mean of $56.42. Population mean is 60. Level of significance is 0.01. By using this function, T period inverse, alpha, and degree of freedom, I got the cutoff point. Okay, now I know the cutoff point is 2 minus 2.485, rounded to 3 decimal. So the cutoff point is, this cutoff point is minus 2.485. Okay, so step 4 is done. I have identified the rejection region clearly. Now let's go and do step 5. So in step 5, we need to find the t-value of x bar. Because sigma is unknown, I'm going to use t-value to find the test statistic, t-value formula. So I need this formula. T is x bar minus mu over S. Sigma is unknown. I have sample standard deviation over square root of n. By using this formula, we need to find t-value of x bar. If x bar or t-value of x bar falls in the rejection region, I'm going to reject H0. If the t-value of x bar doesn't fall in the rejection region, it means it falls on the right side of minus 2.485. If t-value of x bar is on the right side of cutoff point, then it falls within don't reject H0. And in this case, we don't reject H0. Let's go to Excel to find t-value of x bar. X bar is 56.42, mu is 60, S 10.04, and n is 26. Look at here, I have all the information here. Look at the formula. I'm going to find the t-value of x bar. X bar minus mu over s divided by square root of n. First, let's find s over square root of n. S is 10.04 divided by s square root of n. How much is n? 26 sample size. Okay, now it's time to find t-value of x bar. X bar is 56.42 minus mu or 60 divided by this number, s over square root of n. It's the t-value of x bar. Look at t-value is minus 1.81. Rounded, if we keep 3 decimal, minus 1.818. So, look at here, look at here, now I'm working with t distribution. Okay, instead of x bar, now we are going with t distribution. So, in the middle, I have 0. Okay, t distribution is 0 center. In the middle, we have 0. So, the t value of x bar minus 1.818 is on the right side of the cutoff point. We are almost here. Here is minus 1.818. Okay, look at here. It's the t-value of x bar. T-value of x bar doesn't fall in the rejection region. It's in the don't reject H0. So now step 6. In step 6, we conclude. Let me write that here. Step 6. Because t-value doesn't fall. Okay, look at here in step 6. So t-value does not fall in the rejection region. In the reject region. So we do not reject. We do not reject H0. Okay, H0 says mu population mean is more than or equal to 60. So it means it is not shown that the cost cutting measures reduce the mean daily spend. Okay, so it's the conclusion. We don't have any. So it is not shown that the cost cutting measures have made a reduction in the mean daily spend of the students.